Uh, Hello everyone. So this is our last question for midterm one review, and here in my early video I posted is about like how you can calculate return on asset and through like decomposing return on asset and all the stuffs. And in our lecture videos, I went through like what are the um questions you need to practice more for the exam one. So. As I said, like I'm going to make weekly videos on this last question, and here it is, uh, just to showing you like how you can do these things. All right. So the how collaterals can reduce the risk of a loan. Uh, we can start from the first one. So there is like startup farm currently owned 100% by the original entrepreneur, and there are some all information. Um, and so the main information is the initial investment is $100 and the time one cash flow 0, there's a 70% of chance, or 484, there's a 25% of chance, right? Like, so there is a two likelihood, like it can happen or it's not happen, right? So if it happens, there is 70% of chance that for, for the 0 and the 25% chance that you are going to get 484. So the expected time one cash flow for the 0, the first part is 75. So we multiply the probability to get the expected value. So the 484, and this is the probability for 0.25. So thus we, as it is 0, so we just get 25% chance for 484, right? So we get $1 for expected time one cash flow. So this is like for after 1 year. So when you discount it for the present value, there is a 10% cost of capital, the discount rate. So 1 plus 0.10. Uh, and you discount the 121 for 1 year, thus you get the value here, and you have your initial initial investment -100. You already paid it, and you are expected to get cash flow on that, and the difference is like $10, right? So there is a positive NPV for this part of the problem. All right. So now go to some like advanced way. Okay, so the asset in place was 0 for state one, the 75% chance, and there are like 25% chance for state two. And the growth opportunity of the project 0, and in the after 1 year there is 484, and there is 484 for the total. We have already done this in the previous one. And the initial investment is 100, and there is a bank requires a 5% expected return on loans. And uh, what about the borrowing the $100 from a bank? So we have to like analyze like, is this a correct decision or not for borrowing $100? All right. So the expected return, we already said that we multiply probability with the cash flow. So here our probability for state one is 0.75, and the for state two is 0.25, and the cash flow is 0 for first one, and the cash flow for 485 like amount loaned here. So if we loan $100 for this for here, like you see, like what about borrowing the 100 from the bank? So if I borrow $100 and there is a uh, rate here, uh, if it's just 30% interest rate 1 year loan, so I just multiply the interest rate, so my cash flow is $100 and with the additional interest rate of 1.3. And then what we have to do, we have like this CF1 0, and we have CF2, multiply this, and we will get the value and the probability. So the CF1 probability is 0.75 and the CF2 probability is 0.25, right? We have these things here. So here you can see like the probability just calculated there, and you get 32.5 for time one expected cash flow in here, right? So the expected return what? So we got expected return by our this value, like time one expected cash flow over the amount loan, the amount I'm borrowing, and I that the amount. So I make the difference between the total amount one and the expected return. So if it is like positive, so then I can compare with that 5%. And if it's negative NPV, so I'm going to reject it, right? So the expected return here, 32.5, we have already here, and over 100. And when you, so there, it should be like this way, so it would be easier for you to understand. Okay, so when you divide 32.5 over 100, this should be a very like fraction amount, right? Like less than 1. So we have like negative 7.5%. So you're not going to take this loan, right? Because this is less than your 5% of the bank's required return. You get it? So the thing is like you have to think about your interest rate 1 plus r here, and you need to find out the cash flow 1 and cash flow 2, which is already given to you, and you just calculate these things to compare with your required return, right? What else? Okay, so um, what promise you? Okay, so now here they are not saying your interest rate. So how you can get the interest rate of for the bank to charge? So this is the formula here given to you. So everything was same earlier. We put here like 3%, but now we are not putting here 3% to adjust for this 5%, just to make the uh, like equivalent value, just to get the same amount, right? So you can just do some like algebraic expression, the equation, just left hand side, and then you got the equation for r and all this value calculated, and then you make go them to the right hand side, and you done the calculation, you got 3.2 or 320%. So the banks need to charge a 320% promised interest rate on the loan to earn a 5% expected return. So to make it 5%, you have to charge interest at 320%. You remember the last time we found, like when you charge only 3%, there is negative 67.5%, which is way less than your expected return. So for the 5% with this given information, you need to just 320% for the interest rate, right? Same things here. This is like a new test just to change the values here. Like earlier you have here 0, 0 and different, but the same thing, same formula, just go with the cash flow 1, cash flow 2, and then you you make it equivalent to 5% to get the R, the interest rate uh, of the bank loan, to get the expected return of 5%. And in that case, there's banks need to charge 35% promised interest rate on this loan to get the 5% expected return, right? So if you have the idea like how you like start with the math, so whatever information they ask to you, so you can just solve it. So make sure you know that the cash flow and probability formula, how you can calculate expected return, and how you get the value for R. Then I think you can easily solve the required question in your exam 1. All right. So best of luck to your exam 1, and I hope you have a wonderful exam. And in before exam, if you have any question, any concern or any question, just feel free to reach me. All right. Thank you.